Okay, so where were we? Find the angular velocity of the minute hand of a clock. So if we've got a clock assuming the minute hand, we're just looking at the minute hand made by this circle, find the angular velocity of this minute hand in speed per minute. So the question is, how far is this thing going to move? What angle is going to go through in 1 minute? Well, in order to answer that question, so it's the angular. Well, what is that angular velocity? So all we have to figure out, we're going to know our definition. This is the angle we move through divided by a given time. So let's look at it. And we're looking at a minute hand here, right? So we can look at a few different rotations. We could say in 1 minute, how far does it go? How far does that thing move in 1 minute? Well, heck, I don't know. some number of degrees, right? Well, we don't want to work in degrees. We're working with this unit. Let's measure the radians. We could say that we move through some fraction of 2 pi radians. That makes sense to me because in one circle we go through 2 pi radians, right? 1 full revolution. In our minute hand, if it goes through, 1 full revolution, we've gone through 2 pi radians. So we could say, how far does it go? How long does it take to get through 1 full revolution? That's one way of thinking about this, one way of approaching this thing to solve this problem. We could say in 1 minute, since we're talking about the minute hand, we know that we could choose our unit of time and say, well, how far does that go? How many revolutions does it go through in 1 minute? Now that one, well, how many revolutions? How far is 1 full revolution? Or how many minutes does it take to go through 1 full revolution? Since it's the minute hand, it takes 60 minutes, right? So in 1 minute, how many parts of the revolution did it go through? It went through 1/60th of a full revolution. Right. So it takes you 60 minutes to make 1 full revolution. Then in one single minute, it's gone through 1/60th of a revolution. Also, I could say, how many revolutions does it go through in an hour? Maybe that's how you wanted to approach this. How many revolutions does it go through? Well, in 1 hour, my minute hand goes through. Well, let's see. In half an hour, it goes down to 6. Yeah. In 45 minutes, it comes back up to 9, and in a full hour, it's gone through 1 revolution. So I could say, how much does it go through in 1 minute? It goes through 1/60th of a revolution. I could say, in 1 hour, it goes through 1 revolution. So I've got a few different ways of approaching this thing. Eventually, we're going to have to convert this thing into radians per some amount of speed. So what angle has it gone through? One way or the other, you have to know that throughout this entire revolution, it's gone through 2 pi radians. So Once we have that, figuring out the time it takes to go through that, well, we've already done it. To get through a full revolution, that took us, either 1 hour, if you want to think of it this way, or it's taken 60 minutes. So, what is our angular speed? We've got the distance we travel, 2 pi radians, divided by the amount of time it took us. We could say it had gone 2 pi per hour. So that would be one way of writing our angular speed. We could also have said we go through 2 pi radians every 60 minutes. And that one we would have to reduce a little bit. That one we cancel out our 2 with a 60. We get pi over 30 radians per minute. So a little bit of discussion about where I could start the problem, and then eventually we have to bring it back around to our angle and the amount of time it took. And then we could write our angle either in radians per hour